Hey, hey, it's me again. Okay, so here's another series parallel. I showed this circuit to you in the other video. So because this 3K is in series with the battery, so you're going to wind up with a series circuit. This one is probably one of the easiest ones we have. Okay, so working from this side, working towards the circuit, what do we have? What do we see first? Well, I see 3K is in series with 3K because they only have one point in common. So 3K plus 3K equals 6K ohms. Circle that and redraw that. So now we have 28 volts. We have 3K up here that we didn't do anything with. This 6K we didn't do anything with. And this 6K we didn't do anything with. Okay, so we put the 3K, the 6K, the 6K. 3K plus 3K is 6K. That answer goes in parallel with these other two 6Ks. We have 6K. This 6K is from the series combination. So what do we see now? Actually, I see 6K in parallel at 6K in parallel at 6K. Remember, when they are the same resistor value, you could simply get our total by doing 6K divided by how many do we have? 3. So our total in this case is 2K ohms because they're the same resistor value. Could we do 6K shift reciprocal plus 6K and 6K? Yes, that'll always work. But because they're the same, we just take 6K divided by 3. Last thing we have to do, we didn't do anything with this 3K yet. 3K ohms. But what we did do is basically put all these three together, and that answer of 2K comes here. So now when you have a series circuit as the minimized circuit for a series parallel, you work it just like a regular circuit. You get E total, R total, I total, V3K, and V2K. And V2K and 3K must add up to 28 volts. So we already know E total is 28 volts. R total in a series circuit, we simply add them up. 3K plus 2K is 5K. So now we have to get their current by multiplying 28 volts times 5K. So 28 divided by 5K equals 5.6 milliamps. So 5.6 milliamps. So we know that we have 5.6 milliamps flowing through this circuit, just like this. So what's the current for the 3K? 5.6. What's the current for the 2K? 5.6. This current has no place else to go, so it basically just keeps going in a circle. That's why current, which is the movement, is constant in a series circuit. So now we have to multiply I times R to get E. I times R to get this E. Both of these voltage drops must add up to 28 volts. So we'll do 5.6 milliamps, and I'm going to go save an alpha Z. Okay, or I could just do 5.6 milliamps. So let's do that. 5.6 milli, exponent -3 times 3K equals 16.8 volts. 0.80 volts. Okay, so then we're going to do 5.6 milli times 2K equals 11.2 volts. 11.20 volts. What do these two have to add up to? 28 volts. So we can do 11.20 plus 16.80 equals 28 volts. We know that this circuit is right. Okay, so we can go to the first thing we have circled, which is this 2K ohm. How did we get this 2K ohm? We did the parallel combination. So from this 2K ohm, we have, this is the voltage across, this is the current through. Remember, what's constant in a parallel circuit? Voltage. So this voltage is going to go back here, here, and here. And these three currents must add up to the current here, because this is where it came from. So we put 11.20 volts here, here, and here. So now E divided by R, so 11.20 divided by 6K equals 1.87 milliamps. So 1.87 milliamps here. Since they're the same resistor, they'll have the same current. Milliamps here. And 1.87 milliamps here. When I add these three together, they have to add up to where it came from, which is here, and they do. So now this makes sense. The next thing I have and the last thing I have circled is this 6K. We're talking about this one. How did I get this? I did the series combination. What's constant in a series circuit is current. So from here, do I take this voltage or this current? That's right, current. So this 1.87 milliamps, so times 1.87 milliamps is going to be multiplied by 3K and this 3K. These two voltages must add up to where it came from, so 11.20 volts. So we take 1.87 milli exponent negative 3 times 3K, and I get 5.61 volts. If I have 5.61 volts here, I have to have it here as well because they're the same resistor value. And then we're done. We've gotten the 3K, the voltage across this is 16.80. The current here is 5.6 milliamps, which makes sense because you have to have I total coming in. At this point, does it have any place else to go? No. It's got to fight through this guy. Once it gets here, current will flow there and this way. So we'll have 1.87 milliamps going there. The rest is coming here. When it gets to this point, 1.87 milliamps is coming down and 1.87 milliamps is flowing through here. Then they meet up and they all go home. This one goes this way and then they meet up and they all meet up and they all go home. That's how the current is flowing. Have a nice day. Bye.